In this video, we're going to be talking about organic chemistry. And this video is for those of you who are taking organic chemistry in your first semester in college. Organic chemistry is a chemistry of organic compounds that contain carbon atoms. Carbon likes to form 4 bonds in organic chemistry. Now, let's look at other elements and the number of bonds they like to form in organic chemistry. Here are other elements in organic chemistry and the number of bonds they like to form. Hydrogen, lithium, and sodium, they are in group 1 and they like to form 1 bond in organic chemistry. Beryllium, for example, like to form 2 bonds. Boron like to form 3 bonds. Carbon likes to form 4 bonds. Nitrogen likes to form 3 bonds. Oxygen likes to form 2 bonds. The halogens, fluorine, chlorine, bromine, and iodine, they like to form 1 bond. There are cases, special cases where fluorine, chlorine, bromine, and iodine likes to form 7 bonds. We will not be treating that in this video. We will treat that in a subsequent video. We also have sulfur. We also have phosphorus. Right? Having an understanding of the number of bonds each element likes to form in organic chemistry is very, very important. It serves as a guide whenever you are drawing Lewis structures of compounds in organic chemistry. Water, for instance, with a condensed formula of H2O. Now, to draw the Lewis structure of water, you already have an understanding that oxygen likes to form 2 bonds and hydrogen likes to form 1 bond. Therefore, the Lewis structure of water will look like this. Now, you might be wondering why I didn't draw the hydrogens like this, but I dropped them pointing down. That's because of the effect of lone pairs. Now, from carbon to fluorine, in the second row, all of these elements like to have 8 electrons to attain stability. So, oxygen has 8 electrons, and each bond contains 2 electrons. Therefore, the remaining 2 lone pairs will be here. So these 2 lone pairs are the reason why these bonds are pointing downward. Hydrogen to oxygen, the bond between hydrogen to oxygen is referred to as a H bond. And a H bond is usually formed whenever hydrogen is directly attached to oxygen, to nitrogen, and to fluorine. Whenever you see hydrogen directly attached to any of these 3 elements, the bond that is formed is referred to as a H bond, or you call it a hydrogen bond. Now, let's say you want to draw the Lewis structure of methyl fluoride with a condensed structure like CH3F, right? Now, how do you draw the Lewis structure of this compound? This is the way you draw the Lewis structure. Carbon likes to form 4 bonds, so you place it in the middle. Hydrogen and fluorine both like to form 1 bond, so this is how it will take. This is the shape it will take. This is the best Lewis structure of methyl fluoride we can make. Now, another thing I want you to notice the polarity. The bond between carbon and fluorine is a polar bond, but the bond between carbon and hydrogen is a non-polar bond. Why is that? Carbon is partially positive and fluorine is partially negative, right? And that means that this is a polar bond. Another thing I want you to take note is the electronegativity value of each of the elements. Fluorine has an electronegativity value of 4.0. Carbon has an electronegativity value of 2.5. And hydrogen has an electronegativity value of 2.1. Now, whenever you see the electronegativity difference between 2 elements bonded together is 0.5 or more, that bond that exists between those 2 elements is a polar bond. So for carbon and fluorine, the difference, when you subtract 2.5 from 4.0, what you get is 1.5. And that tells you that carbon to fluorine bond is a polar bond. But when you see the bond between carbon and hydrogen, When you subtract 2.1 from 2.5, what you get is 0.4. And that means that the bond is a non-polar bond. Another thing again is hydrogen is also partially positive. Now, next I want us to look at the alkane series so that it will help us to give us a guide in drawing Lewis structures of compounds. Before we look at the alkane series, please let's look at the alkane general formula. This general formula is what gives us an insight of how the series of alkane looks like. Now, the general formula of alkane is CN2HN plus 2. Take for instance, you want to maybe find the formula of an alkane that has maybe 4 carbon chain. For a 4 carbon chain, using this formula, wherever you see N, you place 4. So you say C4H2 open bracket 4 plus 2. Right? So what you get now will be C4H 2 times 4 is 8 plus 2 is 10. So you still put 10. So this is a formula for a carbon chain, a 4 carbon chain. And this is referred to as butane. Right? Take for instance, you want to calculate for a 2 carbon chain. Wherever you see N, you place 2. So you have something like C2H2 open bracket 2 open bracket plus close bracket plus 2. Right? Therefore, you have C2. 2 times 2 is what? 4 plus 2, 6. Therefore, you have H6. And this is known as ethane. Right? So this is how you use a general formula of alkane to find the alkane series. So let's take a quick look at the alkane series from 1 to 10. So this is how the alkane series looks like. For a 1 carbon chain, you call it metane. For a 2 carbon chain, you call it ethane. For a 3 carbon chain, you call it propane. 4, you call it butane. 5, you call it pentane. 6, you call it hexane. 7, heptane. 8, octane. 9, nonane. And 10, decane. Please, you just have to memorize, learn this alkane series at least from 1 to 10 so that it will help you when you are studying organic chemistry. How can we draw the Lewis structure of these 3 compounds? Now, to draw the Lewis structure of these 3 compounds, A, B, and C, this is how the Lewis structure of the 3 compounds will look like. For A, it has all single bonds, and therefore it is termed as a saturated compound. For B, you take note that carbon has only 3 bonds, and we already established earlier that carbon likes to form 4 bonds. So therefore, you add another bond between the carbon to carbon. For C, carbon has just 2 bonds. And to make carbon has 4 bonds, which is what it likes to have in organic chemistry, you add 2 extra bonds. And these 2 bonds we are adding are referred to as sigma bond. The first bond is a pi bond, and the 2 bonds are sigma bond. The first bond is a pi bond, the one is a sigma bond. Right? Now, when you look at these 3 compounds, talking about bond strength, the strength between the carbon to carbon bond. For a carbon to carbon single bond, and a carbon to carbon double bond, and a carbon to carbon triple bond, which is stronger? Take for instance, you're having one pencil, and you're having 3 pencils, and you're asked to break 1 pencil and to break 3 pencils simultaneously. Which do you think will be difficult or stronger to break? The triple bond, right? So therefore, a carbon to carbon triple bond is stronger than a carbon to carbon double bond, and a carbon to carbon double bond is stronger than a carbon to carbon single bond. What about their bond length? A carbon to carbon single bond and a carbon to carbon double bond and a carbon to carbon triple bond. Which one is longer? A carbon to carbon single bond has a length of 150 picometers. A carbon to carbon single bond has a length of 133 picometers, and a carbon to carbon triple bond has a 120 picometers. And please note that a triple bond is highly unsaturated. A double bond is unsaturated, and a single bond is saturated. Is that clear? Now what about the bond order? For a bond order BO is pretty straightforward. Whenever you see a carbon to carbon single bond, the bond order is equals to 1. Carbon to carbon double bond, the bond order is 2. Carbon to carbon triple bond, the bond order is 3. Pretty straightforward, right? Good. Now the next thing I want us to look at is calculation of formal charge. Formal charge has a formula for calculating it. The formula of formal charge is Fc is equal to Ve, which represents valence electron, the electrons on the outer shell of the orbiter, and then the number of bonds and the number of dots. Example ABC. Calculate the formal charge of carbon in ABC. How do we go about the calculation of the formal charge of carbon in these three examples? Now for A, formal charge we know is Fc is equals to, what is the valence electrons of carbon? Valence electron of carbon is 4. And carbon in A has 3 bonds. Therefore, you put 3. And then carbon doesn't have a dot, so it's plus 0. So the formal charge is equals to what? Plus 1. Right? Now for B, formal charge Fc is equals to B, carbon has a valence electron of 4, and then carbon has 3 bonds. It has 1 dot, and then the formal charge is 0. One thing I want you to note is that whenever you see carbon having an odd number of valence electron, it tells you, whenever you see carbon having an odd number of dots, what you get is a neutral compound. Now for C, Fc, carbon having 4 valence electron minus, it has 3 bonds plus how many dots? It has 2 dots. Therefore, what you get as a valence electron will be minus 1. Now for compound A, we'll put a plus. For compound B, it's neutral, and compound C will put a minus. Whenever you see plus, it's referred to as a carbocation. Whenever you see 0, it's referred to as neutral. And whenever you see a minus, it's a carb anion. You are looking for the formal charge of sulfur. Now feel free to pause the video and try if you can. The formal charge of sulfur, we know that sulfur has a valence electron of 6. And then in this case, sulfur has just 1 bond, plus sulfur has 6 dots. Therefore, the valence electron is minus 1. You understand? So now let's just go over the whole thing. We look at different compounds and how to draw their Lewis structure. We've understand that carbon to carbon single bond has a longer bond length than a carbon to carbon double bond and triple bond. We know that triple bonds are stronger than double bond, and double bond are stronger than single bond. We know that bond order for a carbon to carbon single bond, the bond order is 1. For a double bond, the bond order is 2. For a triple bond, the bond order is 3. And then we know formal charge are calculated as Fc equals to VE minus B plus D. B standing for the number of bonds, D standing for number of dots, VE standing for number of valence electron. And we have calculated formal charge of 4 different compounds. Now, how can we draw the Lewis structure of these 4 compounds? Identify the compounds and name each of the compounds. Now, to draw the Lewis structure of the following compound, this is how the Lewis structures are drawn. This is how the Lewis structure of the 4 compounds are drawn. Now, to identify the compounds, for compound A, whenever you see carbon carrying an OH at the end of the chain, it's referred to as an alcohol. And whenever you see a carbon chain, like I said, a carbon chain, and then at the end of the chain there's an OH, is referred to as an alcohol. Whenever you see, for B, whenever you see carbon carrying a carbonyl group at the end of the chain, the carbonyl group is a carbon that is double bonded to an oxygen at the end of a chain, and the hydrogen at the end of the chain. Whenever you see a carbonyl group at the end of the chain with an hydrogen, is referred to as an aldehyde. A carbonyl at the end of the chain is referred to as an aldehyde. Aldehyde, right? Now for C, whenever you see oxygen double bonded to 2 carbon atoms, is referred to as an ester, an ether, sorry. Right? Now for the third one, the fourth one, whenever you see a carbonyl group that is found in the middle of the chain, this case the carbonyl group is not found at the end of the chain, it's found at the middle of the chain. Therefore, it's referred to as a ketone. A ketone. It's found at the middle of the chain, is referred to as a ketone. Now, to name these 4 compounds, for the first one, using the alkane series, we know that a 2 carbon chain is referred to as an ethane. But then, when you are naming alcohols, you put ethane, then you take away that E, add OL, so it becomes ethanol. For aldehydes, when you are naming aldehydes, you put, it's 2 carbon chain, right? You put ethane, you take away the E and put AL, become ethanol. For esters, we have 2 methyl group. Therefore, you call it a dimethyl ester. Dimethyl ether. Dimethyl ether. Now, for naming of ketones, you put is a 3 carbon chain, and using it alkane series, we have propane. Now you take away the E and add ONE, it becomes propanol. So that's how you name the 4 examples, the 4 compounds. Here's a classwork for you. How can you draw the Lewis structure of this particular compound? Feel free to pause the video and try. Now, to draw the Lewis structure of this particular compound, this is how the Lewis structure will look like. This is how the Lewis structure will look like. You start with this carbon, and then the carbon is attached to 2 methyl group. You attach the 2 methyl group and then to a hydrogen. This carbon is directly attached to another carbon that is containing OH with a hydrogen, and this carbon is directly attached to another carbon that has 3 carbon atoms. So that is how you draw the Lewis structure of that compound. Now, please feel free to like, subscribe, and share to your friends. And please, if you have any subject you want us to treat, please write down the subject in the comment section below. We would like to see your comment also in the comment section below. Thank you so much for watching.